looking at evals, like how do we evaluate our AI applications over the past few weeks, we have basically learned how AI systems get built. We have seen how we can take a model and fine tune it, how we can control the format, how it answers, how we can control the tone of the model. We also looked at how we can build like RAG systems, where we can ingest company specific data and let the model answer based on that data. And if there is any use case specific information, we can ingest it and let the model answer from that data from vector databases in real time, looking up real time information. And then we also looked at agentic systems, like how to develop agentic systems wherein like a model can do things using tools, MCP, and the multi models, how they do the orchestration and stuff, right? So, but one thing which I would like to say is like once these systems are built, right, and deployed, they are surprisingly very hard to improve, right? It's not like traditional applications wherein like once you have built something, you can improve over the time. Once these systems are built, they are like very hard to improve over the time, right? So users report that the agent feels worse after a change. Like let's say if you deploy an application or deploy an agent, now if you push some changes after that, right, so it feels worse. Like whenever a new model of Anthropic comes, you might have noticed that when 4.7 comes and you are using 4.6, you as a user might have felt that the performance has gone down or the experience is not the same. So, I mean, the experience changes as we make changes to the model. So users have reported that agent feels worse after a change. The team has no way to verify except to guess and check by hand, right? If like users are reporting an issue, right, you don't have any if let's say you don't have an automated way or a plan, how will you check it out, right? You will go in like manually fire in some queries and you'll check whether I'm getting the right answer or not, right? So so when the evals are absent, right, if you don't have an evaluation criteria, debugging is very reactive, right? It means that you only find out what is broken when somebody complains, right? So if you don't have an evaluation system for an AI system, only when the user is complaining or when somebody complains about it, then only you get to know about the issue. So debugging becomes very reactive. But there is a one more greater problem than that. Like engineers can't distinguish a real regression from a random noise. Let's say one user is complaining that, hey, I don't see relevant answers from the bot, right? So how do you identify, because LLMs are non-deterministic, right? So let's say you made a change to the product or you improve something, right? So whether it's a real regression or a random noise, right? You how can you distinguish that, right? So if you don't have evals, that is a problem. So we cannot automatically test a change against hundreds of scenarios, right? So let's say if you have built a bot and like it's answering based on like a document which is like 1,000 pages long, which has a lot of scenarios mentioned in, right? So when you deploy something, you actually cannot, like if you don't have evals, you cannot manually go in and test against hundreds of scenarios, right? And we can't measure whether there is any actual improvement or not, right? So LLMs are non-deterministic. Like I said, the same prompt can give different answers. So we can't go by saying that it looked fine when I tried it once is not an evidence, right? That's exactly the gap evals fill, right? So the point here being is like LLMs are very different from traditional testing, right? In traditional testing, like the output of a function is very deterministic, right? You get a same response even if you execute the test or the function multiple times. But LLMs by nature are non-deterministic. So I can't, as a developer, go in like if I developed an AI system and then I say, hey, it worked on my system, right? So that cannot be an evidence because LLMs are non-deterministic. We need to have a better way to test AI systems, right? So the agenda for today will be we'll look at what are evals, which are basically tests for AI systems. What are human guided evals? How do we start manual dog fooding plus the intuition, right? And then what are automated evals? How can we write automated evals where we'll see how we can use LLM as a judge at scale, right? And then how do we bring in monitoring and observability into AI systems? How do we watch it in the production, right? So what are evals? We'll start with what are evals. Evals are tests for AI systems. Evals are nothing but tests for AI systems. They check the behavior and quality of the AI systems output, right? Simple. Like we have test cases in our normal products. Similar to that, evals is just the word for testing AI systems, right? Evals, like I said, and they check the behavior and the quality of an AI system's output. But like I already mentioned, it's unlike unit test, wherein like let's say if you have a function add 2 plus 2, right? So you can put an assert and see if I call this function add 2 plus 2, whether the output is 4 or not, right? In case of LLMs, the output is a fuzzy text, right? So we need fuzzy but rigorous ways to grade it, right? So that is a challenge where with testing AI systems, right? Outputs are non-deterministic. So how do you test it? Now, even before going, so now let's look at evals from different levels, right? So let's say if I have developed a model, like plain LLM model, I'm not using RAG or any agentic system. So what are the evals available for them, right? For a raw LLM with no tools and no retrieval, evals test general capabilities, right? Whether the model is capable on general terms, right? Whether it's pulling up right answers, whether the reasoning of the model is correct or not, whether it's doing the correct math or not, right? And like we have discussed previously as well, there are certain benchmarks which are like in industry standardized benchmarks, right? We have talked about MMLU, which is massive multitask language understanding, which has like questions from 57 subjects. There are question and answers, and these questions are passed on to the model, and they take and they answer, and then we do a comparison how good the model is doing on these set of questions, right? So these are called general evals, like also benchmarks, right? So MMLU is one benchmark, then GPQA is another benchmark, graduate level Google Proof Q&A, which consists of hard science and expert level questions. Then HELM is another benchmark, which is holistic evaluation of language models, right? So like this, there are certain benchmarks. So whenever a new model comes in, right, we see it on LinkedIn or other places that model X scores 88% on MMLU, 90% on GPQA. So you will see these benchmarks. So this is how they compare the models, different versions of the model on different benchmarks, right? They grade the model, right? But so this was for specific, like when we are fine tuning or building models. So these benchmarks can be used over there. Now let's see how we can evaluate RAG systems, right? Let's say if you have built a RAG pipeline wherein, like, let's say what do? We actually build a vector database. We ingest like company specific documentation or user specific documentation into the vector database. And then when a user passes on a query, we do embed the query also in the using the same embedding model and pull the data from the vector database, right? We do this, and then from the vector database we get certain top 5 or top 10 chunks. We take those chunks and pass it to the LLM, right? Pass it to the LLM along with the original query, right? And then we get the answer. So now the question comes, like, which part should we test, right? So if you look at this life cycle over here, right? So you can see basically we only have a few testable parts, right? First part is like when the user is passing in the query, we are retrieving some chunks from we are embedding the query, and we are retrieving chunks we are doing a similarity search from the vector database and retrieving some chunks, right? So some optimization can be done over here, like maybe when you are embedding or when you are putting some data into vector database, right? Have you chunked the data properly? Or like when you are retrieving the data, whether the right amount of data is coming or not. So we can do the system can be improved over here in this part, right? So we can test this. We should actually, when we evaluate the RAG system, we should test this. And then if you see, like once you get the response, right? Once you get the relevant chunks, then the job of the LLM is to format the response, right? So we should test this, right? That you got all the data. Now, did you correctly format the response or not? So there are two parts of a RAG system which are testable, right? So the first part is retrieval quality. Like I said, did we fetch the right chunks, which is over here, right? So the metrics for that is precision, recall, and relevance. We'll talk about each of them. So how precise, when it pulled the chunks, how precise was it? How relevant was the data? And what are some things, like by testing this, what are some things that we can change after testing this is we can change our chunking strategy and we can change our embedding model. Based on how these metrics perform, we can fine tune these two things in the model, right? We can change our chunking strategy. We can also maybe change our embedding model. The second part is, like I said, the answer quality. The answer quality is like you have got the chunks from the database, and the chunking part and the retrieval part is working correctly. But given good chunks, did we write a good answer to the user, right? So the metrics through which we measure whether the answer quality was good or not is by groundedness, answer relevancy, correctness, and what if some of these metrics are not good? What can we change? We can change the system prompt over here. So this is the changeable parameter, the knob you can turn, right? So why have we changed it into two parts, right? Why are we taking retrieval quality and answer quality separately? So if the final answer is bad, right, you need to know whose fault it is, right? Let's say if you have not chunked the documents correctly itself, then there can be a problem over here. And if you have not provided the right prompt over here, maybe you are getting right data from the database, but because of your prompt, it's a problem over here also. Second problem can be over here. So we have to test both of these parts, because when we are not getting the right answers, we need to get to the root cause, right? Which of this is faulty? So that is why we split the testing into two parts, whether the retrieval is working correctly in a RAG system or not, or whether the model is formatting the data in the right format or not. So, like I said, bad retrieval, wrong chunks, and bad generation, good chunks, lazy answer, right? Bad retrieval is the problem, that we are retrieving wrong chunks altogether, or bad generation is the problem. Good chunks are there, but the answer is not, the model is not answering correctly. So measuring them separately tells you where to spend your time, right? When you are debugging a RAG system, right? So now let's look at the retrieval quality, right? What are the metrics we use? I said precision, recall, and relevance, right? So what do they actually mean? The retrieval metrics: precision, recall, and relevance, right? So first, even like when you start testing a RAG application, right? So first you have to build a golden data set. What does it mean? Is like, let's say if you are building a medical application or something like that, right? So you need an SME or an industry expert who knows about the field, right? So now you have built a RAG application which is answering some, let's say some medical related answers, right? You have built an bot which can answer some medical related information. So in order to test it, first you need to have a golden data set, wherein like you need to have an SME, and you need to tell that SME that, hey, I have built this bot, but what do you think? Can you give me like 15-20 questions which you think which you think the answer should be this? Like, provide me the question and also the answer, right? So that is being called as the golden data set over here. Without this, none of the metrics would work out, right? So this is also called as the ground truth, right? And then what do we do? So like I said, the labeled set is your answer key, right? We'll have both question and the answer, right? So now first and foremost, in order to what did we look at? In order to evaluate any of the AI systems, we'll always need to have a golden data set. What is golden data set? Golden data set is like, we need to have a subject matter expert with us, and whatever AI application we are building, the around whatever context we are building it, right? The SME should have knowledge, and we'll ask the SME that, hey, I have built this bot, now give me top 15 questions, and along with that, answers that you think the bot should be able to answer, right? So now see what basically we'll ask him. Like, let's say if I'm building a chatbot which helps in refund, right? So I will ask him a set of questions wherein I'll ask him to provide me the golden data set, which will have the query, like what is the refund window maybe. And then what will happen is, like, let's say when we evaluate any of the when we evaluate any of the RAG systems, right? So what we do is, we generally keep in mind like what is the refund window, like the query should be there. Now what we see is, let's say the SME told me that the answer should be in these three paragraphs, right? C1, C2, C5, C9, right? So he gave me that these are the correct answers, or the paragraphs from the doc which contain the right answer, right? So now when what I will do is, I will keep this as a ground truth for myself, and then what I will do is, I will pass the same question to the model, and then I will see what all paragraphs did it pick up, or what all chunks did it pick up. So let's say the SME had told me that C2, C5, C9 are the correct paragraphs, and I am pulling up top five. So I see C2, C5, my model, like when I did a semantic search on a vector database, I got these paragraphs, right? So I can see that the SME had said that the correct answer will be from C2, C5, and C9. But I can see some additional paragraphs also being pulled up over here. So now let's see at what is precision, precision K, right? So what it says is, of what I fetched, which is like this part, right? Of what I fetched, how much was useful, right? Which means is, like, the SME had given me, or the golden data set has had, like, for this particular question, these three paragraphs are useful. I have fetched C2, C7, C5, C1, C8. So I fetched this. How much was it useful? So I can see C2 can be useful, C5 can be useful, nothing else, right? So 2 out of 5. So my precision K is 0.40, right? 2, so this was the right amount of, I pulled five paragraphs in total, And then out of them, only two were marked as useful, right, by the SME. So I can see that the precision of my system is 0.40, right? So when do we use it? Whenever LLM gets distracted by noise, like let's say low, if you measure the score or what precision K will tell you is like LLM is pulling a lot of noise, or like it's not pulling the relevant chunks, right? So what it means, you are stuffing the prompt with irrelevant chunks. Okay. So when we are pulling the data and passing on to the LLM to format the answer, we are putting in a lot of irrelevant chunks. So that is what precision K. So if the precision K is higher, which means that the accuracy of our RAG system is higher, right? Now, these two are the standard parameters. First is like precision K. The next one is recall K. What does recall K means? Of all the right chunks, how many did I catch, right? So these were my right chunks, right? Three, right? Which was marked by the SME. In my response, which was here, how many did I catch? C2 and C5. So what will it be? Relevant retrieved, what versus total relevant 2 by 3, which is 0.69. I miss C9. So this is my recall K, right? A percentage kind of thing. So use it when answers are incomplete, right? What it can say is like if your recall K is better, right? So it means that your RAG application is pulling right context or right number of answers. If it's low, it means that it's not pulling the right chunks, right? It's not getting the right amount of data, right? So that is what precision K and recall K measures. These two are really important metrics via which you measure the efficiency of a RAG application, right? So let's say, what can these parameters say? Like if we have a low recall K, right, answers will feel incomplete. You will feel that the answer is there, but maybe something is missing in the answer. You might expect something more in the answer, right? So what can you see? What can you fix if the recall K is low? You might want to smaller down the chunks or use a better embedding model, right? And then let's say if you have a low precision K, right, then what happens is answers are there, but they are off topic, means relevant chunks are not getting picked up. So there is a difference, right? Here you are feeling that the answer is incomplete, right? When you have a low recall K, and here what you are feeling is answers are off topic, low precision K, right? So then we maybe we need to add a re-ranker, okay, in our RAG workflow. So this is how basically we can test any of these are two important metrics via which we can measure our RAG application, which is like precision K and recall K. These are really important metrics to measure, right? We'll see how we can, how do we actually measure it? Like what's the process towards the end, that how can you measure? There are some out of the box tools present. I'll discuss about that. But for now, let's move into, like, we know now how we can test RAG applications, right? But how do we test agentic systems, right? Because agents, like we had discussed, they can do stuff, right? So they have an outcome, they follow a process, and whether it's safe or not, we need to test that. Agents can do things. So we can check three layers basically for agents, right? First is outcome. Did it succeed or not? So we had given a goal to the agent. So did it successfully do the task or not? Whether the task was successful or not. And like recall K and precision K, there is a pass K parameter on a benchmark, right? Process selection. Did it work right? Right? Tool call traces. We'll look at the tool call traces and we'll see what was the accuracy and the ordering selection, right? Did it did it pull the right tools and did it use it in the right sequence, right? We can check that. And safety. The third thing we can check is safety. Did it stay safe? Like, did it, like, since the agents work in a loop, right? Were they hallucinating or not? We'll look at the tool call traces and we'll see whether there are any hallucinations, whether any toxicity is there or not, and whether they are adhering to some guardrails or not. So if I have only given it access to certain tools, whether it's staying in those limits or it's trying to access something else or not, we can check all those things. So for agentic systems, the evaluation criteria is different. We'll not look at recall K and precision K, but we'll look at outcome. What was the outcome, whether it was able to achieve that goal or not, what process it followed to achieve that goal, and whether it stayed safe or not. A system is evaluated on the parameters that are measurable and changeable, right? It makes sense also, right? I would, what it means is, like, if I'm evaluating a system, I will anyways, I mean, I should test it on what is changeable, right? I should change them. I should test the moving parts, so that if I'm not getting good responses, or if my goal is not achieved, then I can change those parameters, right? That is how we should test it, right? Our system should be evaluated concretely. You don't evaluate what you can't change. Pick metrics that point at a knob you can actually turn, right? It's self-explanatory. We should evaluate systems on points on what optimizations can be done, right? So like for example, a RAG based system can be checked for answer relevance, cannot be checked for tool calling order, right? Because in a RAG system there is no tool calling, so we can only check for answer relevance. Whereas if we have an agentic flow, can be checked for tool calling order, because in agentic systems we do tool calling, right? So this was like we looked at how do we evaluate RAG systems and how do we evaluate agentic systems, right? Now let's move into the third part, which is like human guided evals, right? So these were some metrics. Okay, whatever we discussed till now, if you see, these are the metrics on which we should evaluate a system. So if I have to evaluate a RAG system, I will evaluate it on precision K and recall K. So these are two metrics that I will measure, right? Similarly, for agentic system, maybe like I said, pass K, or maybe how the outcome was. Maybe for process selection, right, there might be another metric. I have not put it down over here, but we have to look at the tool call traces and figure it out. Maybe accuracy K might be another metric. So this is how these are the metrics on which we can evaluate AI systems, right? Now, so these are the metrics that we should look for. Now, how do we get those metrics, right? So there are two different ways. One is like as a human, you go in, and another is automatic way, right? So first you first is like you can think of it as like manual testing and automated testing, right? So first look at manual testing, right? So human guided evals, that is nothing but manual testing. When building agents, we start with manual testing, dog fooding and intuition. What does dog fooding means? It means using your own product like a real user before anyone else does it. It means like after you have developed a system, you go in as a real user and test all the scenarios, not just unit test, but try to like test the system end to end with different capabilities or functionalities, whatever you have built in into your system, right? So generally the life cycle of a shipping an agent looks like this, right? So you build something, you build an agent or an application, and then you use evals, right? After the building of the application is done, you create an eval set with the help of subject matter expert, like I said, and then you evaluate whether on the criteria or the benchmark that I'm trying to set, is it passing right now or not? If it's not passing, if the eval scores are not good, you go back and then you fix the agentic system, right? Or the rack system, whatever it is, right? And then once the evals are passing, then only we deploy it to the customer. So we follow the same build, eval, and deploy loop over here, right? So what is the process? Generally, what we'll follow is SME creates 20 to 50 user queries that are important to get right, right? So we'll, like I said, we'll work with the SME and we'll tell that, hey, I've built this system medical bot or something, and then ask him to give me 50 questions that you think that the bot should answer correctly. It's a must have, right? So SME will give me, then we as engineers will run the queries as input to the agent and note the responses, right? This is a manual process. Okay, so the SME created the Q&A document for me, and as an engineer, I pass those queries to the agent and note the responses. Now, if it's not performing well, we as engineer change the system prompt, right? Preferably with SME's guidance. Maybe SME can also help us that, hey, your prompt was this, you can change it to this, right? The system is evaluated again on the same prompts, continue until it's deployable, right? Same testing cycle like we follow, right? If something is not working correctly, the QA team tests it, then again goes back to the development team make changes, and then again same set of eval is run on the same thing until and unless we are happy with the results, we don't deploy it to the customers. So that's a standard QA practice that we should follow with AI systems as well. We can take an example, like let's say if you have built a support bot, and if your query is how do I get a refund after 30 days, right? So this was one of the questions in your evals, right? So initially V1 answer you get from the bot is you can't, sorry, just this, right? Nothing else. So the SME tells you, hey, this is not right, it's too blunt and wrong, right? Maybe then you, what as a developer you might need to go in and do is change the prompt. Hey, when answering, add a policy doc plus cite the exception clause, right? So whenever you are answering anything, give the policy document also, and if there are any exceptions, cite the exception clause, right? So after you make a change in the prompt, you can see the V2 answer. After 30 days, refunds need manager's approval. Here's how to request it. So initially it just said you cannot, you can't, sorry. And then after we change the prompt, the behavior changed, right? So now the SME says that it's correct and kind. It should not be blunt, and we use the same query and we see the measurable improvement, and we do it across all the evals, like all the Q&A in our eval set, right? So when the answer is bad, don't just change the prompt randomly, localize the failures. Okay, we'll look at this part also, but this is like one part wherein like how we can see what is the workflow, like how can we improve, right? Now let's look at one more important point is, right? Many people think that when the RAG application, when we are not getting right answers, one option which randomly comes to the mind is, hey, let's try changing the prompt, right? Because it's let's try changing the prompt, because that is why maybe the application is not behaving correctly. But we should not just think in terms of prompt, but we should try to localize the failure, right? We need to identify what is the root cause, right? Is a retrieval the root cause? Like, are we fetching the right information from the vector B, DB or not? Chunking, this is so most of the RAG applications fail because chunking is not correct, right? Wrong chunks are being fetched. If wrong chunks itself are being fetched, how will the LLM give you right answers, right? Then agentic systems can fail in the tool discovery part. If the description of the tool is not proper, we had seen, right, we need to pass the JSON schema to the so that the tool call happens, right? So if the tool name and description is not proper, LLM will not know the tool is the right fit or not. So we should look at our tool descriptions also, whether it's right or not. And then the tool calling, whether this can also become a problem, whether the arguments which we are passing to the tool are I mean, whether the LLM is taking the passing the right arguments to the tool calling, the response type is correct or not. So the main thing about this flow is not only I mean, things in AI application don't only go at a prompt. You cannot just fix the prompt. You have to identify the root cause. The problem can be at retrieval or at the prompt level. So you have to identify the root cause and then fix it. Each root cause has a different fix. You don't rewrite the prompt when the real problem is bad chunking size, right? So you can keep on rewriting the prompt, but you will never get right answers if the right chunks are not being fetched from the RAG system. So that is one example. Okay. So that was about like which areas when a RAG system is not performing correctly, what are the metrics we should measure, and how should we troubleshoot the application, and what is the flow, how can we take the SME help and all those things, right? Now let's compare it like how should we like when we create the eval, right? How should we create the eval, right? What are the things that we can keep in mind, right? So once real users arrive, study user query patterns, right? In our normal applications, which are not AI applications, we cannot build effective databases indexes without knowing the data access pattern of the users, right? Similarly, we can't build effective evals without knowing the user query patterns, right? We have built a RAG application, but we have to keep in consideration that what are the user query patterns, right? So you have to keep two things in mind, look out for two patterns. What kind of queries do users usually ask, right? What is the most frequently asked questions, right? Frequency based queries, which questions are the users looking answer for the most, and then what query stresses dissatisfy the user the most, right? So which queries we should also look at these patterns, like which questions is the user most dissatisfied with, right? Which queries or traces dissatisfy the user the most, right? And when we are doing the evals, when we are creating the evals, so this is like after you have gone live, right? Because how will you know the user query pattern if you have not gone live, right? So this is like after you have gone live, you should still evolve the evals, right? You should look at what kind of queries users are actually asking, and what queries dissatisfy the users the most, right? So your eval sets should be dominated by the high frequency queries, cover the common cases, and the high pain queries also, right? So a good eval should cover all these questions, right? You should keep in mind these things. Now, what are the benefits of human evals, right? We have looked at manual testing, which is like human evaluation. So the benefit of human evaluation is basically like it covers most important queries in the app, right? We obviously know, we work with an SME and we know that if I'm building a medical bot, what are the most important use case, right? I can quickly find that out. Builds domain specific response patterns the LLM should follow, right? Like it means like we know that what are the how should the LLM response, or what domain specific question should be there, right? As an SME, we know that. So that is where these are the benefits of human evaluation, that I can know, hey, these 20-30 questions should be there in the evaluation criteria. But there are drawbacks as well, like it's not scalable. If you have a very big, like let's say you have taken you are building a RAG application where you have taken the confluence of the entire company, and there are hundreds of teams within inside the company, right? So in that case, human evaluation is tough because you can't go reach out to 100 teams and 100 SMEs and then build like evals around it, right? So it's not scalable, and also it's expensive because needs real SME time, right? Their hours are costly, right? So this was all about like human evals, which is like manual testing. Now let's look at what are automated evals. So when we create, so these are like automation testing. So here, what the interesting part is, we use LLMs itself as a judge, right? So what if we use LLM or a panel of LLMs to judge your own system responses? Instead of an SME grading every answer, an LLM grader or a judge scores them at machine scale. So what it means is like once the responses are produced by an LLM, right? Why can't we use another LLM to judge the response, right? So let's say the user passes in a query, it goes to the system where you have the server plus the LLM tools, and the LLM gives a response, right? Now what you will do with the responses, you will pass it to another set of LLMs, which will act as a judge. Okay, and then they will look at different judges will look at different criterias and see how and rate the responses, right? Whether it was good, whether it was bad, or whether how good was the response from the LLM. So if you look at a surface level, it might look as a circular thing. You might think as a circular dependency, an LLM checking an LLM, right? You have an agent LLM and you are passing the output again to a judge LLM. Both are LLMs only. So a common confusion point over here could be, hey, both are LLMs only. So if the agent LLM has produced an answer, the judge LLM will obviously give say that the answer is right. So but that's not the case. What we use generally in case of when LLM as a judge is used, right? So the agent LLM maybe can be a lower model, maybe 4.7 opus, and the judge model can be a higher model, 4.8 opus, or maybe different or maybe models from different families, right? So what it helps is like then their viewpoint or on whether the answer is right or wrong can be different. Maybe if they are from the same family, like 4.7 here, 4.7 here from the opus family, maybe you will always get, the judge will always say, LLM as a judge will always give you like, hey, there's no problem in the answer. But when you use like one when the agent LLM is opus, maybe over here you use codex, or maybe here 4.7, here 4.8, then LLMs can also like help you evaluate whether the answers are coming correctly or not. So initially, that's why where I said it seems like a cyclic dependency, but since the system prompts and therefore the goals of the two LLMs are different, we can assume one LLM can judge the other, right? So here, like I said, the goals are different. The agent LLM, what is the goal of the agent LLM? You are a helpful support agent. What is the goal of the judge LLM? You are a strict grader of X, right? You are a judge. So their goals are different. So maybe we can use this two we are using this same LLMs but differently, right? Their goals are same. So we can use LLM as judge as well. The judge can be a more powerful model than the agent LLM, like I said, right? Now, what should be the judging metrics when we are creating LLM, when we are using the LLM as a judge? We should look at the generation quality, right? You are building a RAG application and the model gave you an answer, right? So now you are using LLM as a judge. So now what are the or how will you design the prompt of the judge and what should you look at? So what metrics we should look at? So generation quality, we should look at answer relevance, which means whether the answer generated is on topic or to the point, right? Whether it's on topic or off topic, right? Whether it's grounded or not, which means like which also means like faithfulness, like claims are backed by the source material. So you gave an answer, from where did you give the answer? So that is groundedness, from the materials that were provided to you or not, or whether you gave it like LLMs have hallucinate a lot, right? So even it can happen is like it can give you some you asked a question and it will just give it from its it will just give it to you a generic answer, whereas you might have provided a documentation which might have a specific answer also, right? So instead of using that doc, it gave you a generic answer on its own, right? So then the answer is not grounded. While when it's answering from the doc in a RAG application and it gave you reference that in my answer I referred this doc, then it's considered as grounded. Okay. What is coherence? Coherence means it should not be too verbose. It should have a logical flow of thoughts, right? So we should measure. So when I'm measuring the output, right, of my system, I should check all these metrics, right? Hey, was the answer relevant or not? So you will ask one of the judges to check whether, hey, whether the answer that I got over here is relevant or not. Hey, whether the answer is grounded or not. What sources were cited and are they really present or not? Hey, whether it's coherent or not. Hey, whether it's complete or not. No missing information should be there. And topic adherence, like sticks to the topic even when the user asks irrelevant things, right? It should stick to the topic. Now these are like generation quality, like the LLM got all the chunks, and then how did it generate the answer, right? There are when we are using LLM as a judge, we should also take a look at retrieval quality. Generation is like you got the chunks and how you formatted the answer. Retrieval quality is like when you retrieve the chunks, how good was the chunking strategy or how good was the retrieval, which is context relevance, right? Checks the retrieval quality where the fetch chunks useful or not. So context relevance is like to answer a question, your user query and fetch some picked your user query, you embedded it, right? And you fetch some chunks from the vector database. So context relevance means is whether you are fetching the right chunks from the database or not, or is something going wrong during the semantic matching from the vector database. It could be because of your chunking strategy or maybe because of the embedding model. So we should check the retrieval quality also, right? And noise sensitivity, add irrelevant docs to the context on purpose, then see how robust the generation stays, right? So add some irrelevant docs also to the vector database and see if the correct thing is coming or not, right? So don't get confused between groundedness and relevancy. See, groundedness means relevancy asks, does the answer address the question, right? Relevancy asks, does the answer address the question? Groundedness asks, is the answer actually supported by the retrieved documents, right? Groundedness is telling, hey, did you get the answer? Did you fetch the answer from the docs which I have embedded in the vector DB itself, right? How did you stick to what I suggested you to stick to? Like these are my docs. Did you stick to those docs? And the 11th is like when you are giving the answer, does the answer address the question or not, right? And then there can be different judging styles as well. Like you can see, you can do a point-wise judgment. You can rate whether this is the right answer or the wrong answer. You can do pairwise judging, which is like I have two answers, which one is more correct, right? You can have list wise judging, which is like I have given you five responses, now rank them, which one in like in terms of relevance or in terms of rightness, which one is more right, one from 1 to 5, give a rank, right? So these are the different judging styles which can be used. So all these points which we are talking about, they will be a part of the prompt. So when you use LLM as a judge, right, you will tell the LLM, hey, judge it point wise, hey, judge it pair wise, hey, judge it list wise, right? When should we use what is like point wise judgment should be done when we just want to check whether the answer is a pass or fail, right? You will just tell it, hey, tell me whether this answer is right or not. When you want that kind of judgment, you use point wise, right? When you want pair wise for regression, right, you have released v1, v1 was giving some response and v2 is giving some response, right? You are asking the LLM to generate two different responses, maybe from model 1 and model 2, and then you are using LLM as a just to check whether v1 is better or v2 is better, or whether when you are doing regression check. And list wise, like when you are tuning a ranking or retrieval, when you are tuning a ranking or a retrieval component, right? Like when you are doing re-ranking or something, you can see you can tell it to answer it list wise so that you can see whether a re-ranker is required or not, right? Now, best practices for LLM as a judge. So all these points come under LLM as a judge. Why I have like kept it as an elaborate section is because we'll be using all of this, right? This is what will be used. You'll be using it in practice. So you should know that when I'm framing the prompt of a LLM as a judge, what things should I keep in mind or how should it work, right? So that is why it is very important, right? So now best practices is like each judge will have like we saw over here, right? We can have multiple judges, okay? So the best practice is each judge should do one thing only. One should like we can have multiple judge, and one judge can look at answer relevancy, one can look at faithfulness, one can look at context relevance. Obviously we cannot have more because cost is involved, because the more number of judges you have, the more number of LLM calls, and then there's a cost component involved. But whatever you want your application, let's say you want your application to be highly accurate, highly relevant, so choose some parameters based on that, and then each judge should only then have multiple judges, and then each judge should only judge one of the parameters, right? And then responses should be binary, right? This is a very critical point. Always keep the responses as binary, right? Whether it's right or wrong. I don't want something third in between, right? Because let's say it gives you a elaborate answer which has some which might be right or which might have some context, or then you cannot judge it properly, right? You just tell it whether it's right or not, because in between scale does not make any sense, right? Let's say you tell it to scale to rate the answer on a scale of 0 to 10. Then how do you know? Let's say it scores it 5. how do you know whether the my system is working correctly or not? So you should always tell it to rank the responses in binary. And we should also consider certain biases. Now LLMs, on the basis of how they are trained, right, some of them have certain biases, right? So this we have already discussed. Scope should be one judge per metric, right? Formal responses should be binary 0 or 1, right? Vague rating like 1 to 10 answers drift. Binary is reproducible and easy to aggregate, right? We already discussed this. Now the third point, bias has been considered or not. We should consider bias, like we should look at right, LLM judges have known and documented biases, like based on the training or the model that you are using as a judge, right? It may be that a model is trained to like long response answers, right? So you have to, when you're using LLM as a judge, you need to know about this, or you need to call this out, that I'm using a model which actually loves long response biases, right? So it got two answers, one was short and one was long. Even before looking at like which would have been a good answer, it will choose that long. If it's a long answer, it's correct, right? So if there is a bias like that, we have to fix it by capping or normalizing the response size. So let's say if you are using a LLM as a judge and it has a bias that it always prefers first response, right? So you are doing a pairwise judgment and judge favors whatever come first, right? So we need to fix, how will we fix it, or how will we prompt it to give the right answer? Evaluate each pair in both directions, AB and BA, right? So we have to change the prompt. When we see such kind of biases, we have to change the prompt in such a way that evaluate each pair in both directions, AB and BA. Then self-preference bias. A model rates its own outputs higher, right? If you see that I am getting a response from my RAG system, wherein like I'm getting the response from two models. One model is the model which I'm using as a judge, and one model is a different model. So a model can have a bias. To fix that, the answers which are coming from its own group, it will say that it's right answer, right? So we can fix that by obfuscating which model wrote it, use a jury of different models instead of one judge, right? We can use different judges, right? So generally, when we are using LLM as a judge also, generally what happens is judge returns a verdict. We have an eval set basically, and we are using LLM as a judge. Then after we get the verdict of the judge, we go in and maybe we can manually fix the prompt if that can fix an issue, or Google has also automated that process. Think about it like you developed an application, then you are passing the responses to a LLM to judge it, and then based on like if things are going wrong, the judge there is a system which goes in and fix the AI system also, right? So that is a automated way. So I think it's not yet it's like not fully functional right now, but I think Google developed one such system called Alpha Evolve, wherein like the whole process is automated. You have a system, you have an AI system, it generates some responses, and you have a LLM as a judge, and based on the output of the judge, like whatever output it is giving, like it's evolving automatically, it's correcting the AI system over here. So yeah, but we don't need to go into these details right now, but I wanted to let you know that these kind of systems are also possible, right? Now, one more important thing which you should always keep in mind, which is very, very important, is you should never trust a single run, right? Remember the whole reason we started, we can't tell a real regression from noise, right? LLMs are non-deterministic. So one run proves nothing. We know LLMs are non-deterministic. You give a question and ask the same question 5 times, it will give you 5 different answers. Maybe the wordings can change, but it will obviously not keep the same. It will generate different answers. It's not deterministic that every time it will give the same answers. So if I have to test a system, right, I should never depend on a single run. Every query or every test in my eval should run n times, right? 5 to 10 times, score every run, and then compare the averages, not single outputs, right? So this is like very, very important when you are evaluating any AI system, right? So like let's say like if you have a query, what's the refund window, right? You run it 5 times and then you see the relevancy scores, right? For the first run, was it relevant? Maybe for the second run, it did not give relevant answer. For the third run, it did. Fourth run, it did. Fifth run, it did not. Maybe you change something in the your system and then you check the V2 relevancy scores. You see that all the 5 times it gave the right answers. Then only you can say, if you just like do a comparison based on single run, you are definitely, you cannot definitely say that the changes that you have made are correct, right? So that is why you need to take an average. This is a must have when you are evaluating any LLM application, right? So this is just one example explaining the same thing. If V1 had scored, let's say 4 times out of 5 it was relevant, you had a score of 0.80. And V2, maybe again the same thing, the runs are different. See over here, the fourth run did not give relevant answer. Here the second run did not give relevant answer. So you will have 0.80 and 0.6. The improvement you thought you saw in one lucky run would vanish. That's noise, and you correctly caught it, right? So that is how averaging will helps us, right? So this was like some tips around like how should we, what should the eval set look like? How should we develop the evals? Now we have talked a lot about metrics and what should the evals look like, right? But do we need to always build it from the scratch? Let's look at the tooling landscape for it, right? So we don't build all of this from scratch. RAG metrics, we talked about certain RAG metrics, right? So there are certain tools which support those metrics like recall K and precision K. RAGAS is a famous framework which supports precision K and recall K and groundedness. And then if you have to use LLM as a judge, deep eval, TrueLens, or prompt foo supports it. And tracing plus eval platform, Langsmith is a popular framework. Brain Trust, then Arise Phoenix, and all those things can be used, right? So you don't have to, whatever we talked about, right? Whatever your eval set should contain, what are the metrics, or if you want to use LLM as a judge, and you want to design the prompts, you don't have to do it from scratch. RAGAS is there for metrics and deep eval. These two are like really important, and Langsmith for observability, right? So we can use these three tools. Example of how they fit in together is wrap your RAG app with Langsmith, right? First step is you will you will wrap your RAG app with Langsmith, right? Every query response trace is logged. If you when you wrap the RAG app with Langsmith, every query response trace is logged, right? This will happen automatically. Now point ragas at those traces, right? Now you point ragas at those traces. Now raga, what will it do? Ragas, what it will do is it will auto compute recall K and precision K and groundedness for your golden set, right? It will automatically do it because you had you have used Langsmith, and Langsmith is monitoring all your responses, and then you pointed ragas to the logs, and then it can automatically calculate recall K and precision K. And then if you want to use LLM as a judge, add deep eval in the CI, in your CI systems, right? On every pull request, rerun the 50 query set, block the merge if average score drops, like we do with test cases, right? If the test cases are 80% passed, then only the merge is successful. If not, then it's not. So we do the same thing. The third step is the real payoff because evals become a regression gate, right? Like I said, just like unit test block a code merge, and eval drops blocks a bad prompt or a model merge automatically. Okay. Now, so this was like what tools can we use. Now the final part, which is monitoring and observability. I think this is the last part which we'll be covering today. So what have we seen? Traditional distributed systems use logging, tracing, and aggregates to monitor the overall health of the system, right? We have a server, we have traces, and we have a data. Generally, they go into different tools like Splunk, Datadog, and all those things, and we measure what is the cost of the application, what is the latency of the application, what is the error rate, maybe what is the server load, right? We have dashboards which measure it, and we have admins which monitor these dashboards, right? So AI natives, if you have an AI native system, along with all these things, what you should add is classic metrics tell you the system is up or not. It's not telling you whether it's good or not. See, it's a measure of whatever we are measuring previously is whether the system is up or not. But now we need to measure whether it's good or not, right? AI systems degrade silently. Nothing throws a 500. The answers just quietly get worse. So in addition to the 4-hour monitor, we also need to monitor whether the AI system is still good or not, right? Whether it's giving the right answer or not. So we should measure user feedback. If in our application, if we have whether you liked an answer, thumbs up or thumbs down, we should measure, right, the reports, whether thumbs up or thumbs down, are users really happy or not? And the judge scores, right? If you obviously for every, when you have gone into production, for every query you cannot run LLM as a judge, right? You will do some sampling and run it only for important queries, or just do random sampling. So we should look at the judge scores, or how the LLM as a judge told you. Run your LLM judge on live traffic and watch for drift, a slow slide in scores over time. Okay, so this is how, apart from when we are doing observability for AI systems, apart from measuring whether the system is up or not, we should measure whether it's giving relevant answers or not, and we can do it via these two parameters, which is like user feedback and judging scores, right? So this was how we can implement. Now the final thing, this I'll take a Swiss cheese model analogy and explain. that no single layer of eval is perfect. Each has certain problems, right? Manual evals have certain problem, automated evals have certain problem, and maybe observability has certain problems also, right? So, but when we stack them together, right, and a failure has to slip through every layer holes to reach the user, right? So when a problem happens, if we have multi layers of like protection, it's bound that it will not slip through all the layers, right? So that is what the Swiss cheese model says. If you can see that if there are certain problems, maybe it passed through the first layer. If you can see over here, it passed through the first layer, then it will be blocked at the second layer. Something passed the first and the second, something passed the first and the second layer, but it got blocked at the third layer. So we should have all the three in our place: manual evals, automated evals, and production monitoring. Manual evals will have high quality and catches subtle domain errors, right? Because these are handmade. We see whether the core business logic is working correctly or not, or whether we are getting the must-haves are correct or not. Automated evals, high volume, catches regression at scale. Now manual evals will check whether the business logic is right or not. Automated evals, like when we are making changes in the system or if the volume is high, whether it's working correctly or not. And production monitoring catches what only shows up with real users plus drift, right? So this is how we test basically an AI system end to end. These are what evals are. They are very, really, really important. You should you should start thinking about evals right from scratch. Most of the AI applications fail because they don't have the right evals in place. So whenever developing an AI application, think from the perspective of evals as well. Okay, thank you. I had this for today.